My name is Leon and this is On Lightness. This month we have a conversation with Dr. Thomas Speck, who is the head of the Botanical Gardens of Freiburg. He's a passionate botanist. He's a professor at the University of Freiburg, as well as a biomimicry expert who collaborated frequently with architects and engineers from the University of Stuttgart, Jan Knippers and Achim Menges, to build these exemplary pavilions that are inspired by principles from nature. I had this conversation with him in February in the middle of the Botanical Gardens, and I hope you enjoy it as much as I did. I want to ask you to briefly describe how you found your way to being here the head of the Freiburg Botanical Gardens while working and teaching in the field of bionics. And I'm especially interested how your interest in bionics started, or how you went from this functional morphology, which maybe you can also explain shortly, how this came to be that you went into bionics.
So my path to bionics was really not a straight one. Originally I started biology because I was very much interested in bioacoustics. My idea was, because I'm a frog lover, I like frogs very much, to understand about bioacoustics in frogs. And then I realized to do bioacoustic in frogs, I had to kill the poor animals. So I ended up to do my first research on fruit flies, Drosophila. And my first paper is on color vision of Drosophila. Well, it was very interesting, and then at that time it was more or less top-notch to work with primates, with monkeys. And I had a PhD position where I should work with monkeys with implanted electrodes, which was absolutely, state of the art, the best thing you could do at that time. And then I realized I can't do it. It was a very interesting project, and the results are really great, a wonderful science. But my personal feeling was, I can't do it. I can't do this with these animals. And so I was a bit desperate, and I worked as a studentic helper in a botanic garden. And the director of the botanic garden, he was a paleontologist. He asked me, I've heard, you have perhaps another idea what to do. And I said, actually, I have no idea. Biomechanics I'm very much interested in. And he said, yes, I'm also interested in biomechanics. I have no idea about biomechanics, but I would be interested how early land plants made it 450 million years ago from water to land. Mm-hmm. And so I did my first work on simulations of early land plants. And by this, I realized that one has to know much more on recent plants to make these calculations, because we need numbers for the mechanics of the different tissues and stuff like that. And so I started also to look at extant plants in close collaboration with a colleague of mine, Nick Rowe from Montpellier. We worked a lot in French Guiana and in Brazil, and did a lot of work on lianas, semicell supporters, how they grow, what is the structure, function, form relationship. So we are relatively very close already at functional morphology. So we try to understand these plants. I was far, far away from bionics still, and especially far away from applications. And then I was invited by Werner Nachtigall, he's more or less the godfather of bionics in Germany, to give a talk on, what can we learn from lianas for bio-inspired applications. And I told him, no, can't do that. I'm a basic researcher, I have no idea about applications. And I said, I think there's quite a bit in. And then I went to a conference of him, and I totally get fixed interested. I'm more or less on the hook of bionics, because I thought, fantastic. You can really link basic research with application and give back something. It sounds a bit, very, I can't say, you can give something back to the public. A lot of our work is public funded, and it's great if you have the idea. You don't do it just for publications. Perhaps you can really a bit help make a world a bit better. And from that on, it's about 25 years ago, I was very much interested in biomimetics, or bionics as it's called in Germany. And first stuff I did was actually with plants, lightweight structures, lianas, what can we learn from them? So we are developed, inspired by bamboo and by horsetails, so-called technical plant stem, an ultra lightweight structure with functional canals in. And it went on, and my focus on biomimetics became broader and broader. And about 15 years ago, in our competence network in Baden-Württemberg, our biomimetics competence network, we collaborated or started to collaborate with the Stuttgart architects, with Knippers and Achim Menges. And this was my way into architecture. And then I realized it's absolutely fantastic to collaborate with architects, because beforehand we collaborated a lot with industry. And to come into a mass market, it takes a long, long time if you make it at all. We have quite a few patents, and some patents are held by our industrial partners, and some of them are never really built. And this is different in architecture. They build stuff. Okay, often they make a kind of research pavilion or stuff like that, but at least they make one of its kind, and you can test your ideas under full public load, under visiting people. And this was a start on my collaboration with architects, and lightweight constructions from the very beginning were one of the main issues. The other one is shading.
Mm-hmm. Okay, so is Werner Nachtigaller in the bionics a bit what Frei Otto might be for architects, as a bio-inspired, like this big pioneer in a way? Or
I think he was. I think he was definitely in the 60s, 70s. He was in the German-speaking countries. He was the person doing bionics, and he has published quite a few books. And I think he's really a kind of godfather of German bionics. Yeah, and I was really fascinated because he saw before me the potential of this plant-inspired bionics, because beforehand, Velcro is plant-inspired. But a lot of other stuff, which was absolutely top-notch in the 70s, 80s, was about movement, flying. So it was mostly inspired by animals. This dramatically changed with the lotus effect, the self-cleaning surfaces by Willem Bartlett and Christoph Nijenhuis. But at that time, when I came in, it was really mostly animals. And yeah, it was just fantastic. And I'm all my life, I will be thankful to him to invite me to this conference, and to give me the chance to find more or less what I really like to do.
Mm-hmm. Perfect. So we're going to talk about lightness as in the lack of weight.
Mm-hmm.
And for each segment, I will read a short idea that I have towards the subject. So, as Mr. Julian Vincent said, in nature, shape is cheap, but material is expensive. For example, dandelion seeds are designed to react to wind. They undock from this head of the seeds to generate an uplift to travel great distances by air. And at the same time, the hair-like structure also serves as both a parachute and a tool to anchor the seed to the ground for germination. So this is just one very classic example of the beauty of fragile nature in a way, which makes you understand that the shapes that nature designs to address challenges are incredibly complex, far more intricate than those constructed in our built environment. So one thing, a lot of these questions I ask from a very naive and amateur viewpoint, of course. Why do you think nature's creations are inherently lightweight?
Yeah, you mentioned Julian Vincent, a good friend of mine, and I have to more or less cite him again. He said a couple of years ago at a conference, we should really rephrase Darwin's famous words on survival of the fittest in survival of the cheapest. Because it's a bit selective advantage during evolution to produce a system which is good enough with as little weight and as little material as possible. And as you already mentioned, nature is very good in structuring. All natural buildings, so to say, we have analyzed now, are structured on at least 5, more often 7 to 8 hierarchical levels. This starts, if we look at a tree, to the entire tree, the amount of cortex, wood, and pith. Then how is the wood structured in coniferous early wood, which has very thin walls, mainly does water conduction and late wood, which very stiff wood, very thick vowel cells, mainly for mechanics. Then on the next level, it's how the wood cells are structured as to their, let me say, valves by which they can exchange water. Then we go to the cell walls. So the cellulose microfibrils might have different angles, and even on a chemical level, amount of cellulose, amount of lignin, structure of lignin, plants may modulate their mechanical properties on all these levels. And this is a dream still for technical applications. But for me, and this I think is very much important, we can learn here from nature for sustainability. Because it's widespread misunderstandings that nature is sustainable. Sustainability is a man-made concept, a teleological concept. You do something for reaching a goal. It traces back to the 18th century, where a German forester said, we can only lock down as much wood as regrows in the next generation, so that they still have enough wood. And this is teleologic. You do something with an aim. And nature is future blind, evolution is future blind. So if we say, okay, sustainability can't be inspired by nature, it's true in a way as evolution works, but it can be inspired if you look at the products of evolution, which are typically very lightweight, wonderfully organized in different hierarchical levels as to their structure. Because nature, I can mainly speak on plants, the materials of plants are very limited. What do we have? You have cellulose, lignin, Hemi-Cellulose, Pektins. Okay, perhaps some mineralic inclusions. Compared to what we have in a technical world where you have, I would say, millions of different materials. We have a very little number of these materials. And because of this small number of materials, nature has really optimized structuring. And I think this is one of the most important things we can transfer from nature to bio-inspired products, material systems, because structure is a way to use material very efficiently, and by this to stay lightweight.
Mm-hmm. Wow, it's an interesting insight to the materialities of plants, that it's such a limited amount. I didn't know this.
I can send you a paper I've published with young Knippers a couple of years ago, which especially deals with that, because this is often overlooked, that the limitation at the end is a strength. Yeah. And this is something we can also learn in architecture, that we say, okay, we can go back to very, very, let me say, good materials, bio-based materials. We have just to think about how to use them and how to arrange them.
Yeah. I also think that there is a lot of historical examples where the scarcity of material led to innovation and led to lightweight construction. You don't have so much, so you have to think more about how to use it and less. This is also probably a reason why our built environment is so overweight, because we have so many materials and we love to tell ourselves that we have an endless supply of them. Yeah. And this is the result of it.
Actually, it was said a couple of years ago that the next war will be for sand. Because for making concrete, you can't use the sand which you find on the beaches. You need a specific sand type, and which is becoming more and more rare worldwide. And only this saying shows, okay, sand for us normally thinks it's an endless resource, but even this resource is limited, like water. And for that, I think we should really go back, and if we look at old buildings like these Fachwerkhaus, which we have in Germany quite a bit, my grandma, she had a farm, and this was made out of this wonderful Fachwerk. And you have wooden frames which hold it together. Then you have interwoven willow, let me say, panels, and then you put clay on it. And they are incredibly stable in a way that they are stable but also flexible. I've never heard about a Fachwerkhaus which broke down due to an earthquake, because they can a bit move with it. And there are many, many advantages in these things, and they can be also easily repaired, because at the end they are modular.
Yeah, I think Fachwerkhäuser...
Do you know the English term, by the way?
Yeah, good question. I don't really know. I'm going to find out later and say it. Yeah. But I think they're incredible. I think they need like a
Absolutely.
like a renaissance, because they are modular. You can deconstruct them. They are only made from biological products in a way. And often also in old constructions, sometimes they stand on these stones, like to elevate
so
them
that's a wood doesn't rot away. So they have a kind of a stony, let me say, funding, and they build on that, and this avoids rotting away. And I think many of these buildings last for centuries. And if you look at our building, and this is another problem we still have in a private housing, we still build like we would build the Cathedral of France. And if you really look at it, a normal private house doesn't last much longer than maximum 2 generations. Then it's either broken down or entirely refurbished. And this we have to keep in mind. This is another advantage nature has. Nature always builds for a given lifetime. And I think we should really rethink about that. I'm not the person to say, okay, after 70 years your house should rot away over your head. This is definitely not necessary. But you can really think about using materials, constructions in a way that they are, on one hand, easy to be replaced or to be renovated, so in a modular way. Or on the other hand, so to say, oh, hey, I have a material which has a given lifetime, which also forces me to do something new, perhaps to improve it. And this is a lot of stuff we can really learn from nature. This limited lifetime is another aspect, which I think should also go into the heads of the architects.
Yeah. You also sometimes feel like our built environment is just a result of, oh, now we have this problem, let's throw some new material at it, and things get fatter and fatter, and you feel like you have to solve more and more things, and you don't really look at what is the most innovative or lightweight way to have solutions for certain functions. Also separate functions. You don't have to have a universal structure that is the solution to everything.
So in France, with a wonderful word, the assurance to risk, which means an assurance for everything. On the other hand, I think what's also very much interesting, which nature tells us, a lot of nature's material systems, I say by purpose material systems, not materials, they are multifunctional. And you could really think about combining different functions in a material system, in a lightweight material systems in buildings. And in my opinion, okay, I also own a private house. Okay, we looked at there as little concrete in as possible. We used a lot of stone stuff and so on, which is pretty good also for kind of noise insulation and stuff like that, and also for heat insulation. But nevertheless, you normally build a house once in your lifetime. And you want to be on a safe side, let me say it that way. And this stops innovation in a private building. But I think a lot of, let me say, governmental buildings, university buildings, as now in Stuttgart, it's done with a new research center they built mainly out of wood. In Stuttgart, there is a lot of potential to show what's possible and to be more or less, as a role model for other stuff.
Yeah, I agree. Okay, let's see what else I have here. Yeah. So maybe we can also talk about what some people might find problematic in bionics, right? I'm sure you heard this a lot, that people maybe question if we should play God or technify nature in a way. What is your standpoint when people say this?
I think bionics or biomimetics has no problems with it because we do not interfere with the genome. This is totally different with biotechnology. A lot of my colleagues who do brilliant work and also very helpful work for humans in biotechnology hear that. You play God, you interfere with the genome, that's no good. Okay, but it has to be tremendously careful. I have this opinion too. Bionics normally has a very positive, seeing from the public, because we use ideas from nature, transfer them, abstract them, and then build something new, typically with technical materials, sometimes with bio-based materials. So biomimetics, up to now, has little problems with this idea of, you play God. I see more problematic some developments. We have, for example, in the US, not recently, but it started 10 years ago, where the idea is nature is good. Everything which comes from nature is good. And this is a way which transfers biomimetics or biomimicry, how they call it, a bit closer to a kind of religion. And I think, okay, that's absolutely stupid, because there are many solutions where we have no chance to use bioinspiration. Because, for example, turning wheels on an exile, there exists one example in nature. This is a flagellum of a bacterium which really turns. The rest nature doesn't do, because a wheel-driven movement is problematic if you are in an energetic sink. So if you are downhill in a valley, it's very, very energy. You need a lot of energy to come up. And therefore, nature never invented real wheels for movement. But there are many other things where nature can help us. And what surprised us, we have just published a paper, I can send you a copy if you're interested, with colleagues from psychology. And they do acceptance research. And they used our bio-inspired buildings, the fiber pavilion. We had a very old one from the 70s, a roof structure in a zoological lecture hall, which was inspired by the bone structure of the femur. And the other one is a bionic shell we have in the technical faculty. And they asked the laypersons about sustainability and how they like it. And some were informed that it's bio-inspired and the others not. And it doesn't make any difference. So bio-inspiration is nice to have, but doesn't improve the acceptance or the ideas that it might be sustainable. And this was surprising to us totally, because they thought, okay, if they get the information it's bio-inspired, they think it's definitely more sustainable. That's not true. And this was really interesting for us. We didn't expect that, but it helps us to understand that bio-inspiration is for many people something nice to have, but at the end they look at the result, and if it's then bio-inspired or not, it doesn't matter so much.
Has to be economical.
It has to be economical, and I think also sustainability plays a role. It has to be aesthetic, and this is interesting, and this especially plays a role in our motile systems and facade shading systems. Biological movements are normally rated at very aesthetic. And if you can transfer not only the functionality, but also the aesthetics, for me this is a king's way of biomimetics. And we did the same with our fiber pavilion, which was inspired by the wood structure of cacti. It also looks very aesthetic. And I think it's very hard for me to coin really what is beauty. It's very complicated. But I think a lot of our feeling for aesthetic in movements, in structures, really comes from the natural environment. It is perhaps even inherited. And that's what we can do a lot over there, and it's especially important in architecture. If I improve an impeller pump for a combustion engine in a car, aesthetics doesn't play a role at all because nobody sees it. Their only function matters. But in architecture, I think both matters, and biomimetics or bio-inspiration gives us a chance to combine it. High functionality, little material, little energy, and a lot of aesthetics.
Let's shortly talk about you met Frei Otto. What was the context? Because I have a question about how I think Frei Otto categorically was against bionics, at least in the beginning of his work. At the same time, he obviously built these models that translated forms found in nature. He used it for form finding based on his models. Then
the pneu structures and stuff like that.
Yeah.
I was invited in some conferences of the SEB 230, 230, and I gave talks. I was at the very beginning of my PhD. At that time, I still worked mainly on early land plants, started just to work on lianas, and they were interested on a structure-function relationship. And Frei Otto always said, I'm not doing bionics. I explain the biologists how nature works. So he was really self-confident in that way. And he said, okay, I do not need inspiration from nature. I have enough inspiration myself. And I found him really an interesting person. For me, I'm trained as a biophysicist, so I really come from the hardcore physical part of biology. He was a mixture between a visionary and somebody who really did a lot of, constructional work. And it's really fantastic to see. But at the end, I did it for some lectures I gave to my students. The number of buildings he made is very small. This is, I think this is something at the World Exhibition in Canada. Then there's something in the Zoological Garden in Munich. Okay, then the famous stadium in Munich, Olympic Stadium in Munich, but he didn't build it. The idea comes from him, build it was by other persons. And this is also another thing where I think a lot of misunderstanding comes from. The roofing of the Olympia Stadium in Munich is often said it's inspired by spider webs. And this is definitely not true. It looks a bit like that, but spider webs are extraordinarily flexible. And this thing is stiff like hell. It has to be stiff like hell. And it's also not really lightweight because the anchoring of the cables, if you go downstairs, there's a huge amount of concrete built to stabilize it. So it has to be really careful. And it's definitely not bio-inspired. It has a kind of biological optics. So it's biomorphic. It's the same with the Sagrada Familia. It's also said, is it bionics? No, it's biomorphic. He used inspiration from trees, how they look, how they branch. And this is built in Sagrada Familia. But he never really analyzed biology before to get information. And this, if you want to make bionics, you have to first understand your own model, do the abstraction, do the entire analysis, and then you have to reinvent something new for technical applications or for architecture.
How do you choose which plant is going to inspire you?
That's a very good question. The same question I was asked from colleagues, I can say, we had a collaboration with BMW, and we built, which is patented since years now, an axle carrier, a fiber-reinforced axle carrier. And I will never forget, we had the idea, they came to us, it was lightweight, we had the idea, and then I sat together with my wife and a colleague from Dresden, Christoph Nines, was also part of the group. And we said, okay, we should look at this plant group, at that plant group, we have a look here, a look there. And I will never forget when we walked for lunch. We walked through the Botanic Garden for the engineers from BMW, the green hell. 6,000 of plants, which are a mess. And he said, exactly as you asked, for heaven's sake, why do you know to look at which plants? And the reason is, I would say the three of us together, we have seen perhaps 100,000 plant species or 50,000 plant species, to be more careful, in the microscope. So we look a lot, we know a lot of structures in different plant groups. So we have an idea. And so I asked him back, can you tell me which kind of engine the BMW 7 point something in 17.6 had? And he said, by sure, this was this. This is so-called knowledge in your field. And this is very important. And therefore I always say, okay, for doing bionics or biomimetics, you need experts in different fields and bring them together. They have to have an overlap, ideally, as we have with the Stuttgart colleagues, over about 20%, where we have a knowledge overlap. But 80% is new. And this is one reason why I think to do very successful biomimetics, you should not start from the scratch to study biomimetics. You study engineering, architecture, material science, biology, chemistry, physics, and then go into biomimetics, because then you have your island of competence. If you start, it might be a huge lake, but very shallow. And this is dangerous. But yeah, I think there are some very good, I don't want to blame the colleagues at the University of Applied Sciences. They have some really very good ground-based studies for bionics. But I myself, if my son would have decided to do biomimetics, he's now doing AI, which is something totally different, I would have told him, do something where you can build your center of competence and then go into biomimetics.
Yeah, I think that is, at least in the field of arts, it's also a bit like that. In architecture maybe too, because because architects are fascinated by other disciplines always, and we are in a bit of a generalist communication role often between disciplines, right? So you bring a completely you bring a really valuable standpoint when you have some pre-knowledge in a field where you can...
So some specific knowledge base which the others don't share or don't have, and you can share it. But coming back to your question, how to select the plants, there are two different ways to do bionics. One is called top-down approach or industrial pull. So industry comes to us with questions. They never have problems, as I have learned. They only have challenges or questions, never problems. They come to us and say, typically with a product which may be already on the market. And they say, there is something which could be improved. Do you have an idea? And then we search specifically for this question, either in the plant world, which we mainly do, or animal world, to find something which has something similar to solve during evolution. And then we analyze it and do the normal way. This, in my institute, makes up about, I would say, 70% of our biomimetic research, because we do a lot of research with industries. The other one is what we called bottom-up or biology push. We find something in biology which just fascinates us. I will never forget, we worked on damping material together with UVEX, with BMW and with some other companies to develop highly damping foaming structures. And this started by a photograph. One of our postdocs is married to a Vietnamese lady, and they eat a lot of pomelo. And he made a joke photo of his small daughter with a hollowed out pomelo, and she wore it as a helmet, just for fun. After which the young girl was smiling wonderfully. And then we thought, this pomelo with a thick peel, it might become really a helmet. It might be a very good inspiration for a helmet. And so our work on damping materials inspired by citrus fruit started. This was an extreme example, which was really by chance, because we all laughed and said, fantastic, it's nice, what a nice picture, blah, blah, blah. And then he told us, do you know that this stuff is really, it's very foamy. And let's start. But normally it's that we see something in the greenhouse, something in the field. I did in my time a lot of field trips to the tropics, but you don't have to go to the tropics. You can also look in your backyard. And if you see something which you think, good God, how does it work? How does it function? This may be the start for something totally new. And and this makes about 30%, because this is a process which takes much longer. So the bottom-up process until a product, when the engineers come in, architects come in, typically takes between 5 and 7 years. The top-down process between 2 and 3 years typically.
Okay, interesting. I'm going to switch to the second category of lightness, which is the luminance or brightness. Mm-hmm. So the light falling through a tree canopy is a good example of like a phenomenon that its beauty is really hard to copy. Like the amount of layers of leaves, their shapes, their transparencies, and paired with the movement of the wind, that is quite unforeseeable, generates these complex patterns. Maybe this is like a moment that really embodies the liveliness and fragility of our existence. What role does light play in your work, or do you remember it playing a big role?
It plays a big role because I like light, and I worked a lot in the tropics and in a tropical rainforest. If you have a small clearing and the sun comes in, this is incredible. It's all these filtered lights, a special kind of greenish, bluish light. And then you come to a clearing, or sometimes only a single sun rays go through the canopy. And this is like, wow. And therefore I'm very interested in, especially in my collaboration with architectures, to deal with light. So what we have done in the fiber pavilion, which was, as I said, inspired by the reticulated wood structure of the cactus wood, there we built not only a material light structure, but also an optical light structure. And it's beautiful to stand in this building, in this small pavilion, which is span is about 10 meters, it's about 6 meters high. And if the sun goes in and the different rays come through, it's a bit like a cathedral. I'm not religious at all, but if I would become religious then in such a place. And I have to admit, this building is at the end much more beautiful than I expected it to be. And it's a combination of lightness, material lightness, lightness by the light coming in. And what we don't have there, we have it a bit because it stands in a botanic garden, which is, in my opinion, also important in canopies in forests. This is the sound of the leaves. So you have a full, all your senses, also the smell, they are active. It's light, it's this rustling of the leaves, it's a smell. And this, I think, that's why I think forests are so good to recover and to relax. And this is what we really want to bring into architecture. And therefore our second main field is not lightweight architectures, but sun shading. And there we developed flector-line, flector-fold, sun shading systems, which are also lightweight in a way that they are actuated by pneumatically. So they do not need a lot of energy. So we have the flector-line now outside in a greenhouse, and it needs about 50 to 100 millibars to open and close one of these modules. And what we also built, and this is for me at the moment one of the fascinating things, we built the so-called solar gate. And this is inspired by the scales of pine cones. And you probably know if it's wet, pine cone scales are closed, and if it's dry, they open. And this is at the end, it's much more complicated because there are two bilayer systems coupled. But you can imagine like a bilayer, you have one structure which can shrink if it's dry and expands if it's wet, and a resistance layer, and it's closing and opening. For the pine, it's very important because the pine seeds can only fly if it's dry. They rotate like Samara seeds, and if it's wet, they would just fall down. They would be too heavy again. We are at weight, like the dandelions. And therefore, it's ecologically and evolutionarily very important that you have this system in the pine cones. And we understood and studied this system. We found out that there are two coupled bilayers. It's relatively complicated. And then we also looked at another example, at the silver thistle. Silver thistle is a wonderful plant which has bracts at the outside. It's an asteraceae, so it's like a sunflower. It has a lot of single flowers in the center. And these bracts, they close if it's wet and protects the flowers. And if it's dry and sunny, they open. And what we did, we developed a sun shading system for a building for our bionic shell. And this sun shading system doesn't need any energy at all. It's between two glass slides in a window, and we use the fact that humidity is strictly coupled to heat and sunshine in temperate climates. If it's hot and sunny, it's dry. If it's humid or cloudy, it's wet. And so we use humidity to make a sunshade. So if it's dry and sunny and hot, they close and they shade. And if it's cloudy or wet, they open and let the lights go in. And what's interesting, it's also a bit temperature dependent. And it helps us. In a cold day, the closing is delayed. So in a cold January or February day, where we have no problems with the heat inside, but we would like to have a bit more light in, so the closing, which normally would happen immediately because it's dry, is delayed because of the temperature. And on a hot, warm summer day, where it's warm, but already wet because a thunderstorm is coming, then it's closing earlier. And this is a very nice combination which we try to understand a bit more in detail, so that at the end we could use the same system also in tropical climates. Here we play around with a humidity difference of about 20 to 30%. In the tropics, you have about 10%, but also there it could work because the materials themselves are 4D printed, and you can adjust them to different humidity regimes.
Wow, a whole world unfolding. I think I'm gonna, because it's a good gateway to the feeling of lightness, the third definition. Yeah, I'm going to first read what I wrote here. The feeling of lightness is impossible to think of without having moments of heaviness. Finally, having solved something, is paired with the enormous weight of working on it for a long time. The same way for many people, walking through a natural landscape is a balance to spending most of their time in the built environment. So since both your job and also this environment here is kind of in this crossroad of nature and artificial in a way, what is your balance between the two? And especially, do you sometimes find yourself, maybe I'm thinking, if you look at a plant and you think about what function could this have for a product, that you might lose the lightness you had when you just looked at it, you know?
That's a very interesting question. I've been asked this question in different, let me say, with a slightly different kind of meaning very often. I'm very often asked, do you lose your fascination for evolution by knowing more and more? You ask me something similar with a bit of another context. No, it's totally different. As more as I know, as more fascinated I become. It's incredible what evolution did. It's incredible what nature can do. On the other hand, looking at biomimetics, at lightweight biomimetics, lightweight structures, we have to keep one thing in mind, that for in our cluster of excellence, LIFMATs, living energy autonomous adaptive material systems, we work by purpose not with living materials, not with living cells. Why? Nature is fantastic, no doubt, but nature is limited. Nature works, across that, from minus 40 to plus 40 degrees Celsius. In the pressure regime, take away deep sea levels around 1 bar, plus minus, with a pH between 8 and 6, around 7. Many applications we need in technology have to work at much lower, much higher temperature, much higher pressure, even in vacuum or in pHs where nature would never survive. And that for our idea is to understand nature, to abstract nature, and to reinvent with technical materials. This is the main way we do in our Excellence Cluster LIFMATs. On the other hand, it's absolutely fascinating if we can do it with bio-based materials. Okay, we know then that we limit again, but in some aspects, like in architecture, housing is normally made for humans, and that shares the same, let me say, temperature, pH, pressure limits as nature. Though there is no problem to use bio-based materials. It would be different, for example, for airplanes, for spacecrafts, for many other stuff. But for buildings, I think we can really try to replace technical materials by bio-based materials. And this, for example, we did in this fiber pavilion where we use flex and sisal cords for building these things. And this is a really interesting thinking, because then we use renewable materials. Flex, for example, is one of the oldest materials used by humankind since Stone Age. And it doesn't compete very much with food in the way how it doesn't need very rich soil. It's very, very, let me say, it can be grow in relatively cold, in relatively dry, in relatively hot conditions. So it's always a problem if you use bio-based materials and you would use and you would need a huge amount. Does it compete with food? So, and this was, for example, a problem when the idea was to use biofuel. There's a big problem. You can decide either to grow biofuel or to grow wheat. With flax, it's not the problem, because flax grows in regions or in areas where wheat or potatoes would not grow. And that's why I think flax is a good material, hemp is a good material. And this is what we should keep in mind, the lightness in mind, because it's hard to say. I think lightness is material, is light, sunlight, but lightness is also feeling. For me, it's a feeling. There might be structures which don't look light, but they give me the feeling of lightness because of their internal structure and of my knowledge. And this is something which is sometimes hard to transport. Look, for example, we have built a technical plant stem. Okay, it doesn't look light, but it is light compared to everything with the same mechanical properties made out of metal. So lightness is also a relative thing. And we discussed a lot with designers if there might exist a bionic language in materials or in structures. So you immediately see, oh, this is bio-inspired. And I think it doesn't. So what we have to do to give the feeling of lightness, we have to use all possibilities, all options, material lightness, lightness by, let me say, translucence stuff, but also information to tell people what it's made of. And I think this is what we should do more and more to inform the users about the structures and materials, to inform the users about the structures and materials, the inspiration we took from nature, because they then can much more appreciate what is done. And I think this is what we do a lot in the Botanic Garden, but also with the colleagues from architecture, this outreach. And this becomes more and more important because we can do the best fantastic materials or buildings or whatever. If they are not accepted by the user, then it's lost.
Yeah, you can imagine that this is a big topic in architecture. Always, when you think of something, you feel like you thought of something smart, and then you think about, but no one will notice, or you compare your designs with what people usually like, and you're like, this is completely different. We're not. So this, of course, this interaction, communication is very central, and it's not always easy to do it in a built.
That's why we decided to build a lot of our bio-inspired stuff in the Botanic Garden, because the Botanic Garden is a perfect place to inform people. If I tell somebody, okay, look at this material, it has a Young's modulus system set, it has a specific Young's modulus, also light. Okay, normal people would say, oh, yeah, good. But if I tell them, look, this is inspired by the bamboo, and I can bend down the bamboo to the earth, and it goes back again. It's a mixture of stiffness and flexibility. And if you look at the inside, it's hollow. People are much more aware, and they understand much better. And I think this is a very good way to link botanical gardens or nature entirely with architecture to inform people. And therefore we have a project which is called Learning from Nature in Nature, which runs in the Botanic Gardens. And this is very important because, as you said, very often you are fascinated. You know what you have developed, what you have designed. It's much better than anything on the market. And then the layperson look at them and say, oh, well, this looks very similar. Oh. And it's so disappointing on one side, but it also hinders often very good solutions to make it in the market. And I think information, it's like in politics. A stupid voter is a dangerous voter. And there, a stupid user is not a dangerous, but is a useless user. And therefore, I think we have to do both.
Yeah. I understand. I agree.
By the way, you are an architect by education?
I'm an architect, yeah.
Okay.
So, since we now talked about the many facets of lightness, and also when it comes to feeling lightness, of course, there's both the physical sensation, like you feel light, you're swimming, you feel weightless, or you feel light compared to the heaviness around you, like in a cathedral, you feel light because you're so small, and you're like, but then there's also the mental and emotional lightness. So what are moments of lightness for you?
I have to admit, the most impressive experience I ever had was when I was the first time in the tropical rainforest. This was just a wow moment. Okay, I have been in many forests before. I have been in many greenhouses, botanic gardens. But if you stand the first time in an undisturbed tropical rainforest, you realize how small you are, how unimportant you are, and how wonderful nature is. And this makes you really, really humble. I think nobody who was ever in a rainforest with an open-minded access would destroy nature anymore because it's just so wonderful. Another example, totally different, was I was on a field trip on Svalbard, so Spitsbergen. And the the nothing. You stand there and it's just snow around you, and you stand there and you think, good God, wow, I'm lost. It's not a fear, but not even an uneasy feeling. It's a strange feeling. And these are my two experiences where I felt lightness in two different ways. The one just, wow, fascinating, and the other one was a bit of, feeling lost. And I think, this is my experience to that.
It's beautiful, actually, I think, to take these both types of landscape, and that they can both evoke a feeling of like existence in a way.
Exactly. I felt so full of life in both places. In one place, because it was pretty cold. I was very well, I had very old clothing on it, but nevertheless, the face, it was pretty cold. And so you had to feel, your body has to work. And in the other place, it's just good. You are surrounded by so much life that you think, okay, I'm part of it. And this is another feeling. It traces back to Somerset Maugham, an English writer who said, time drops like honey in the tropics. And that's true. We were in some small camps in a full rainforest and after 2 days you lost time. You stand up at 6:30 because it becomes bright, and you become really tired at 6-7 in the evening. And after 2-3 days, you have no feeling, am I here since 2 weeks or since a day? And you really lose this kind of time feeling. And there I realized that our life is so time-driven in our normal environment. There, okay, you had your 12 hours of light. You had to do what you have to do, or you didn't do it, the other. And this is interesting also. And I think this might be also a point in lightness. This is a feeling of time. I think it's a bit like if you are underwater. You not only lose your weight, if your head is underwater, you also lose a lot of your senses. And you become a bit of a, like a spaceship. And I think this also gives you this for me, it's also a bit of a feeling of lightness, a specific feeling.
Yeah. Okay. One last question is, can you remember one specific moment in your career or life where you felt like this is something really significant? This feels right. This feels like I'm really where I belong in a way.
In a scientific point of view, it's you mean? Okay, but personally, it was the birth of my 2 children. Definitely, this was the wow effect in my life. This was incredible. This is the best thing which ever happened to me and my wife. And but scientifically, I have to say this is really a collaboration with the architects, where I had the feeling perhaps we can really change something. Perhaps we have really a cue to make the world a bit greener. And it was a Sofflecto fin at the very beginning, which he built, which was inspired by the bird of paradise flowers, also a wonderful role model. And this was really the first thing. And then we realized it's also hard work to do it. But at that time we thought, good God, everybody must use it. Everybody has to use it. Okay, it is used. It is very well appreciated. It is no doubt about all. But the impact was smaller than in this, let me say, cheerful moments when you said, okay, it functions, and it functioned exactly as we have predicted.
Yeah. All right, thank you. This was very, very inspiring.
Thank you very much. No, you had very good questions.